Okay, this is a really kind of a tricky problem. Sine plus cosine equals 1. Looks like it's really simple, but sometimes that can be deceiving. So here's the problem is I've got a sine and I've got a cosine. And I'd really like to have just sines or just cosines, but I don't have a way to do that with these unless I should decide that I want to square both sides of this equation. Okay, so what do I get then? Well, if I square this, I get sine squared theta plus 2 sine cosine theta plus another cosine squared theta, and that equals 1. Okay, if you have a hard time with this, just take this and FOIL it. Just set it up as sine plus cosine times sine plus cosine, and FOIL that, and you'll get this. Okay, now a sine squared plus a cosine squared, that's 1. So this is going to simplify to 1 right here. So that's just 1. And this is my double angle formula for sine again. So this is sine 2 theta. And this still equals 1. So the next thing I'm going to do is I'm going to subtract 1 from both sides. And I get sine 2 theta equals 0 plus 2 pi k. Now, why did I add the 2 pi k on this? Because this is going to change the period of sine, so I might get multiple answers. Okay, so I arc sine 2 theta is the arc sine of 0. Whoops, not theta, 0. Plus 2 pi k. And the arc sine of 0 is going to be 0. It's also going to be pi, and it's also going to be 2 pi. So I get 3 sets of equations here. I'm going to get 2 theta is 0 plus 2 pi k. 2 theta is going to be pi plus 2 pi k. And then it's also 2 pi k plus 2 pi k, but that's just the same solutions as this, so we can ignore that one. Okay, so the next thing I'm going to do is I'm going to divide by 2, and I get theta equals 0 plus pi k. And over here, theta equals pi over 2 plus pi k. Okay, so theta gives me 0 as a solution here, obviously. Gives me pi over 2 as a solution. Now, I get another one at, if I add pi to this, so there's another one at pi. I add pi to this, that gives me 3 pi over 2. And then since I checked this out, it has to equal 2 pi. If I add another pi to this, that's 2 pi. So it appears that there's 5 solutions to this. And then we start looking at this really close. So if I plug in 0, I get sine 0 plus cosine 0. That's 0 plus 1. That's 1. That one works. And pi over 2, sine of pi over 2 is 1. Cosine of pi over 2 is 0. So I get 1 plus 0. That's equal to 1. So that one works. So both of these work. Now let's look at pi. If I plug pi into these, sine of 0, or sine of pi is 0. Cosine of pi is negative 1. So 0 plus negative 1 is not equal to 1. This is not really an answer. It's extraneous. Okay, 3 pi over 2, if I plug that in here and here, I get negative 1 here plus 0 equals 1. And that's not true either. So this is also an extraneous answer. Remember, an extraneous answer is an answer that appears and all the math was done correctly, but it doesn't work. Okay, and then I try 2 pi. So if I plug in 2 pi, here's the sine of 2 pi is 0, cosine of 2 pi is 1. So that is also a solution. So there's 3 solutions to this. These two right here are extraneous. They're not really solutions, even though they appear to be. So there's only 3 solutions to this. Now, why did that occur? Well, because I squared this originally. And remember, when you square a negative number, it becomes a positive number. And so that's thrown some error in there. So anytime you're going to square something like this in your problem, you need to really check your answers and make sure that they're all really answers and not extraneous.